Thank you very much, and thank you for inviting us to speak today. So the first half of this evening's talk, well, this evening my time, will be by me, and then I will hand over to Wendy partway through. So to give you some context to our research project, we did some literature surveying of the use of videos in laboratory training for undergraduate students, and came across a lot of really great examples of where the videos are used for pre-lab classes. They're used for teaching students about general chemical safety. They're also used to provide kind of first-person instructor approaches with GoPro cameras, or students are encouraged to record some of the work they've done themselves and upload it for assessment. But what we found was missing was the use of laboratory videos within the actual laboratory class, so that if a student felt that they needed guidance with how to undertake a particular experiment, how to use a piece of equipment, then they had to rely on reading their laboratory manual or speaking to a demonstrator. And with the number of demonstrators being very small relative to a large number of students in a lab class, that can slow things down if students can't get the help when they need it. So what we were looking for was a capacity to provide just-in-time assistance to students as and when they need it. So right in front of them when they're faced with a pile of glassware and they can't quite figure out how to put it together properly. So that was the basis behind the start of this work. So we're lucky at Griffith, like many other universities, that we have available to us the opportunity to apply for small grants for teaching and learning activities, and Wendy and I and another colleague, Mark Costa, put together a research proposal to present, to ask for a small amount of money and some time to allow us to put together these laboratory videos. And we were lucky enough to receive $5,000 towards this activity. But what we got on top of that was access to one of our blended learning team, who was able to do some of our professional filming for us, and that was really important later on. So we wanted, as I said, to create videos that students could view in the lab at the time they were doing the laboratory. So the little graphic there shows our student undertaking the experiment on one side with their dedicated iPad playing the video, and the other they could pause the video, stop it, rewind it, fast forward it, put it in just the place they wanted it, and to repeat watching the activity while they were there. The videos were also available on our LMS, so the more organized of students would have watched the videos the night before they did the laboratory class, but even if they'd failed to do that, it was there to provide them with this just-in-time assistance. So we were able to look at two different modes of filming. The first was using professional cameras and our blended learning team. So we set up two static cameras, digital cameras, which were recording a wide angle shot of the bench space. And a second camera was used for zooming in to provide additional detail. And those videos were recorded with sound, not because we wanted to use the sound for the students, because we removed it from that purpose, but we needed the sound so that the video editing person who wasn't a scientist was able to understand what labels needed to be added to the video so that people could read the label and understand exactly what section of the video related to what aspect. The second lot of videos that we did, we filmed using mobile phones, which allowed us much greater flexibility to film within more constrained environments, like within a fume cupboard, and to be able to have more motion and movement, and so a better idea of exactly what the student should be doing and when they should be doing it. We made sure that all of the videos we created were less than 4 minutes in duration, so that it wasn't going to take students a lot of time to watch the entire video. And again, if they wanted to rewind, they would have plenty of time within their lab class to do that. We annotated them with instructional labels because we didn't want the audio used, mostly because laboratories are always noisy environments with students chatting amongst themselves. And we thought if we have half a dozen different videos playing different parts of the video at different times, then the noise in the laboratory would be too much to deal with. So overall, we recorded 10 different techniques using either the professional video approach, which you can see on the right-hand side of the screen, or with our mobile phone technology, which you can see on the left. So with the mobile phone, we had a small tripod that we could place that on for static shots, but we also had a second scientist filming the person doing the demonstration. With the mobile camera, as I said, it gave us the opportunity to film in more constrained places, and we could work around the demonstrator, which was more challenging with our fixed professional cameras, because sometimes we had to stop and move the demonstrator relative to where the camera filming was to make sure that they weren't on top of one another. So our initial implementation of this was run on a pilot study in 2017 with a third-year class called Instrumental Chemical Techniques, which is a 2-week intensive laboratory class. Students spend 6 hours a day in the lab across 9 days of a 2-week period. There are several different experiments taking place each day, and the students are working in pairs. 3 of those experiments had laboratory videos associated with them, and each pair of students had access to a dedicated iPad. So our technical staff are very wary about allowing technology into the laboratory spaces, but we had these dedicated iPads which live essentially in our third-year chemistry lab. They have replaceable silicone covers. We can mount them on stands, and we've been using them since 2017, and I'm pleased to say they're still going strong, and the students haven't managed to damage them in any of the experiments that they've done. In 2018, we introduced the additional mobile phone filmed experiments in an advanced organic chemistry class, another third-year class, and we have continued using videos in those 2 classes over the past 3 years with some good success. So this is an overview of the techniques and the methods of filming that we have used, and this is the point where I hand over to Wendy to pick up the remainder of our talk. Thank you.
Excellent, thank you, Sarah. I'll just see whether, Dino, if you wouldn't mind putting my video on, please. Okay, so colleagues, what we did through both these courses is that we had, I guess, a juxtaposition of the student demographics in these courses. We had oops, sorry, I'll just get my video on. Thank you, right. Yes, so in the Advanced Organic Chemistry course, we had a high international student load, and you can see that from the previous slide with that we had about 65 international students and about 100 students all up. And they run through a multi-stage experiment over 3 weeks, and so consequently there's multiple techniques that they have to come across, both from the glassware viewpoint, the chemical technique, as well as the instrumental techniques. The other course that Sarah has been talking about, which is third year, is a bit more instrumentation based, and therefore has specific equipment that is targeted more towards forensic chemistry. So what we did between the 2 courses was able to get a representation of, you know, setting up glassware, using a range of equipment, and also looking specifically at various chemical techniques that the students would do, such as distillation, but also things like cutting up sodium metal and thin layer chromatography and things like that. So moving on to the next slide. Thanks, Sarah. We actually had a look at the advantages and disadvantages of each of those techniques, both from the professional filming and the mobile phone. You can see examples of the quality of the images and still shots from the actual videos from the professional filming up the top there. So The advantages certainly included the fact that we did have a professional and high quality cameras doing it, that there was good setback camera positions, which meant that was away from people trying to do experimental procedures. But because of the quality of the camera, you could zoom in very well, which was good. And of course, the professional editing in terms of the production. But what we did find is that this was all done by our educational designers, every, I guess, university has a different term for them, but they're more our professional learning staff. And because they weren't chemists themselves, we had to run the commentary through the filming so that they could help with the annotation and editing stage. We also found the larger tripod equipment could actually be an obstruction, and that we still had to use a chemist in the process of the editing because of the, I guess, quality assurance and checking of what was actually in the video. And generally there was a higher cost associated with all of this with professional camera and production software. So then comparing that now to the mobile phone, these were readily available. There were dynamic angles. We've talked about a lot of this. We had a little bit of problems with just learning production software skills, but we certainly managed to get on top of that. I think we're all learning lots of new online skills at the moment. It was great to have the roaming camera to get on top of, for example, what's happening from a vertical viewpoint, and of course we didn't actually have any phone calls, but it is a possible risk. So, all right, so moving on to the next one, we have started to analyse the student feedback and the student actual usage of these, and then at this stage we're still dealing with the preliminary analysis of that. But here's some of the ideas that came out from what we've done in terms of a preliminary pass at the data. And it was quite clear a lot of the students who responded to the surveys that we ran across multiple years and multiple groups, and we had very good response rates, that we, they were very positive about it, particularly the ability to sort of jump into a video and pause it while they were doing the lab and actually help them with setting it up, for example, steam distillation. And also too, we looked at what the staff felt, and particularly with the international student cohort, we found that this helped a lot with the workload of the staff, because students became a lot more autonomous, and what this meant that the demonstrator could concentrate on the lab as a whole and actually sort of push the higher learning aspects of the labs rather than having to go through the same thing time and time again. And there was one interesting concern that was raised, and this was more by the technical staff, that particularly when we started to have the iPad around fume hoods, there was a concern around the it becoming overcrowded with equipment. So certainly out on the bench tops and places like that, it was a lot better. And I guess it all depends on what your student ratio to fume hoods are and how big your fume hoods are and things like that. All right, so finally, just to summarise before we take some questions, is that we noticed that obviously some of the students had made use of the laboratory on the learning management system. However, virtually all, as 50 to 75% of them still watch the videos on the television screens as well as on the iPads. And it was really quite interesting how about how many students actually actively engaged with them during the laboratory sessions. And it was partly, I think, because of the level of the lab that we're dealing with. We're dealing with Sergi lab, we're dealing with much more complex technical issues and as well as in the case of advanced organic chemistry, synthetic procedures, and so they valued that pausing, rewinding, reviewing key sections. So moving forward, the opportunity to watch an experiment being set up and performed is especially important to demonstrate dynamics of chemical techniques to learners, especially for those that are disadvantaged if instructions are solely in printed form, because we obviously have a range of learners with students. They potentially use instructional videos that could assist, they're interactive, they're instructional, they could hopefully assist experiential learning. But one unexpected advantage is that we found that this has supported the development of the online laboratory experience during the COVID-19 crisis. We had all these videos ready to go. All right, so just finally, I'd like to thank very much David Green and Mark Costa for collegial support, and I also really acknowledge the wonderful work that I do, as Sarah does, and it's been wonderful, many years of collaboration, and I look forward to many years to come. Yeah. Okay, I'd like to leave it there so there's a few minutes for questions. Thank you.